Tennessee's at-home learning series for math. Today's lesson is for all our 7th graders out there, though all children are welcome to tune in. This lesson is the 4th in our series. My name is Kayla Anderson, and I'm an 8th grade teacher in Tennessee schools. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them on the Tennessee Department of Education website, which is www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today we will be learning about inequalities in mathematics. Before we get started, to participate fully in our lesson today, you will need paper, pencil, a surface to write on, a place to copy down some problems that we're going to do on the board. Let's get started. Recall your previous learning when you discussed inequalities. Some things to remember. Remember that this symbol means less than. Remember that this symbol means greater than. Remember that this symbol means less than or equal to. And remember that this symbol means greater than or equal to. I'll pause for just a second so that you can write those things down on your paper if you'd like to have them to refer back to as we progress through the lesson. Okay, so today we will be talking about the properties of inequalities. You may recall that when solving inequalities, sometimes the inequality sign stays the same, and sometimes it's reversed. Let's look at some numeric examples to remind ourselves what this means. Okay, so you'll probably want a place to copy down what we're going to work on now. So we're going to start out with the equality 2 is less than 5. In this place, we're going to be doing an operation and a new inequality where the inequality sign doesn't change. Here, we're going to be doing an operation and a new inequality where the sign is reversed. Okay, so the first thing that we're going to do here is we're going to add 4 to both sides. Okay, so here's my inequality. 2 is less than 5. So I'm going to go ahead and I'm going to add 4. Sorry, that's kind of in the way. So 2 is less than 5 is our inequality. So I'm going to add 4 to both sides. So 2 plus 4 less than, 5 plus 4. Okay, so 2 plus 4 is 6, and 5 plus 4 is 9. 6 is less than 9. Notice that the inequality sign didn't change here, it stayed the same. Over here on this side, we're going to be multiplying both sides by -4. Okay, so still working with that same inequality, 2 times -4. I've got the less than symbol there, and 5 times -4. Okay, so we have the less than symbol from where we started out, but let's think about that for a second. 2 times -4 is -8, and 5 times -4 is -20. Is -8 less than -20? No, -8 is greater than -20. So that inequality symbol actually gets reversed because we multiplied by -4. So when we added 4, the inequality sign stayed the same. When we multiplied by -4, the inequality sign reversed. Let's do a few more examples and see if we can figure out a pattern here. So our next inequality is -4 is greater than -6. While you copy that down, I'll go ahead and get our operations set up for what we're going to do to both sides so that you can copy them down and think about them. So here we're going to be subtracting 3 from both sides. And over here we're going to be dividing by -2. I'll pause for just a second so that you can copy that down and think about it. All right, so we're going to be subtracting 3 from both sides of this inequality. So -4 minus 3, we think we still have our greater than, we're going to figure that out, -6 minus 3. Okay, well -4 take away 3 gives me -7, and -6 take away 3 gives me -9. Is -7 greater than -9? Yeah. So we're going to keep that greater than symbol there. That inequality sign did not get reversed. Okay? On this side, we're going to be taking our inequality and we're going to dividing both sides by -2. So we're going to have -4 divided by -2. Now we started out with a greater than symbol. We're going to see if that remains true. We're also going to do -6 divided by -2. Well, -4 divided by -2 is +2. -6 divided by -2 is 3. Is 2 greater than 3? No, it's not. 2 is less than 3. So we actually need to take that inequality symbol that we started with and we need to flip it around. We need to reverse it. So over here, when we subtracted 3, the inequality symbol didn't change. But when we divided by -2, the inequality symbol got reversed. Take a second and jot that down and think about it while I write down our next example. -1 is less than or equal to 2. -1 is less than or equal to 2. Go ahead and write that one down. So this time, we're going to be multiplying both sides by 3. We're also going to be multiplying both sides by -1. We've done a couple examples together, so I'm going to pause and give you the opportunity to take this inequality and to multiply both sides by 3, see if your inequality symbol gets reversed, and to also multiply both sides by -1 and see if that inequality symbol gets reversed. And then we'll talk about it together. All right, so let's see how you did. We took both of these sides and we're going to multiply by 3. So -1 times 3. We originally had less than or equal to, and then 2 times 3. Let's see how that goes. So -1 times 3 gives me -3, and 2 times 3 gives me 6. Is -3 less than or equal to 6? Yes, it is. So we know that our inequality sign did not reverse or change around here. It started out as less than or equal to, and it stayed less than or equal to. Over here, we're going to multiply both sides by -1. -1 times -1. Again, we started out with the inequality symbol of less than or equal to, and then we have 2 times -1. Well, let's do the math and see if this inequality symbol gets reversed. So -1 times -1 gives me +1. And positive 2 times negative 1 gives me negative 2. Is 1 less than or equal to negative 2? No, it's not. 1 is actually greater than or equal to negative 2. So in this case, that inequality symbol was reversed or flipped around to become greater than or equal to. Okay? So I'll pause for a second in case you need to write any of that down while I get our last example ready so that we can look at this example. Okay, so hopefully you had a chance to copy all of that down. The last example that we're going to do, negative 2 plus negative 3 is less than negative 3 minus 1. Okay, so let's take a look at that one and see what happens. The first thing we're going to be doing to this inequality is adding 5 to both sides. The second thing that we're going to be doing to this inequality is multiplying both sides by negative 1/2. So just like we did on the last example, I'm going to pause and let you work on this and see what you can come up with about when the inequality symbols get reversed. What I want you to start with, though, before you get started on your own, let's look at this inequality and make sure that we even have the right symbol here. Negative 2 plus negative 3 gives me negative 5, and negative 3 minus 1 gives me negative 4. Is negative 5 less than negative 4? It is. So we're going to start out knowing that that less than symbol is correct, and we're going to see what happens to that inequality sign as we add 5 to both sides and as we multiply both sides by negative 1/2. So I'll pause so that you can see how that works out. All right, so let's take a look at it and see how you did. So on this side, we had negative 2 plus negative 3, and we're going to add 5. We've got less than, and then negative 3 minus 1, and we're also going to add 5. We're going to see if that remains true. So we know that negative 2 plus negative 3 is negative 5, and the negative 5 plus 5 is 0. Okay? Then we've got negative 3 minus 1, which we know is negative 4, and negative 4 plus 5 is positive 1. Is 0 less than 1? Yes, it is. So that inequality symbol didn't change. 0 is less than 1, and so we didn't have to flip that inequality around or reverse it. Now here we're going to multiply both sides by negative 1/2. So we've got negative 2 plus negative 3, and we're going to take that and we're going to multiply by negative 1/2. So we know that negative 2 plus negative 3, when we simplified this earlier, was negative 5. And so we're going to multiply that negative 5 times negative 1/2. We've got the less than symbol. We already found out that negative 3 minus 1 is negative 4. So we're going to do negative 4 times negative 1/2 here. So negative 5 times negative 1/2 is positive 5 over 2, which is the same as 2 1/2, if you like to think about it that way. However you feel more confident about that, 5/2 or 2 1/2, same thing. And then negative 4 times negative 1/2 is 2. So is 2 1/2 or 5/2 less than 2? No, it's not. It's greater than 2. So we actually ended up needing to reverse that inequality around to make it greater than. Okay, so now that we've done all of these examples together and we've looked at taking these original inequalities and doing something with them here and doing something with them here, look back at your work for a second and see, did you notice a pattern? I hope that as you look back at this and you think about your work, that you are noticing a pattern. And so I'm going to go ahead and put this up for you to take a look at. So I hope that the pattern that you notice is that when you add or subtract, the inequality sign does not change. When you multiply or divide by a positive number, the inequality sign does not change. However, when you multiply or divide by a negative number, that's when the inequality sign gets reversed around. So adding or subtracting doesn't change the inequality sign. Multiplying or dividing by a positive number doesn't change the inequality sign. It's when you multiply or divide by a negative number that that inequality sign gets reversed. And so if you'll take a look back at what we just did, I think that you'll notice that pattern. Now I'm going to pause for a second because this is really important as we work through solving inequalities that we're going to do for the rest of this lesson. So I'm going to pause in case you'd like to write down this part about what does reverse that inequality sign around. All right, so hopefully you had a chance to jot that down. And we're going to move on now. This knowledge that we've gained is going to help us solve some inequalities. So let's work on that now. So taking these notes or wherever you wrote that, just kind of put them to the side. Take this down. I'll leave that there for you to reference as we work through these examples that we're going to do together. So we want to solve an inequality. We're going to solve for x. So the inequality that we're starting with is x plus 5. Make sure I write this. X plus 5 is less than 8. X plus 5 is less than 8. And we're going to be solving that inequality for x. Now, recall that solving an inequality is very similar to solving an equation. So we're going to use those inverse operations that we would use when solving an equation to solve this inequality. So if I'm trying to isolate the variable or get the x by itself, I'm looking at the fact that we're adding 5, and the inverse operation of adding 5 is subtracting 5. So we are going to subtract 5 from both sides. Okay? Now, subtracting 5 from both sides here leaves me with x, because 5 take away 5 is 0, leaves me with x on this side. And then I have the less than symbol, and 8 take away 5 is 3. So my final answer, I think, is x is less than 3. Now, let's think about, did we need to reverse that inequality symbol around? Remember that when you add or subtract, the inequality does not change. So since we only subtracted here, x minus 3 is my final answer. Now, we can prove that this is the correct answer by evaluating x at a given number. So let's use some number less than 3 to see if it works. So we need x needs to be some number that's less than 3. I'm going to use 2. So when I go back to this inequality here and I replace, so I've got x plus 5 is less than 8, and I'm going to use 2 since 2 is less than 3 and substitute 2 in place of that x. 2 plus 5 is 7, and 7 is less than 8. So, since that number works, using that number that's less than 3 makes this inequality true, we know that x is less than 3 is our answer to this inequality. Okay? So, let's try another example. Okay, so now let's work on, sorry, I want to make sure I get the right example. Let's try another example. So let's do 2x is greater than 10. Go ahead and write that one down. 2x is greater than 10. Okay, so remember that solving inequalities is really similar to solving equations. We're going to use inverse operations. So here I notice that x is being multiplied by 2. And I'm thinking to myself, if I'm trying to isolate that variable, what's the opposite or the inverse operation of multiplying by 2? Well, the inverse of multiplying by 2 is dividing by 2. So I'm going to divide both sides by 2. 2 divided by 2 gives me 1, so I just have x is greater than 10 divided by 2, which is 5. Now we think this is our final answer. We don't think that this inequality flips around. Notice that when you multiply or divide by a positive number, the inequality doesn't change. Well, we did divide by a positive number. That inequality sign is not going to change. So what does that mean? What is this answer telling me? Yeah, it means that any number that's greater than 5 is going to satisfy this inequality. Let's pick a number and prove that. Well, 7 is greater than 5. So if I go back to my original inequality and I substitute 7 in place of x, 2 times 7 is 14, and 14 is greater than 10. So x is greater than 5 is the answer to this inequality. Okay? So remember what we discovered about multiplying and dividing by a negative number? How do you think that affects solving an inequality? Well, let's see by doing another example. Okay? So this time we have the example negative 2x is greater than 10. So again, remember what we discovered about multiplying and dividing by a negative number? How do you think that's going to affect solving this? Why don't you try solving it and see what you come up with? All right, so let's solve it. When I look at x and I'm trying to get x by itself, I'm trying to isolate that variable, I notice that it's being multiplied by negative 2. The inverse operation of multiplying by 2 is to, or excuse me, of multiplying by negative 2 is to divide by negative 2. So I'm going to divide both sides by negative 2. Now, I'm keeping that same, and negative 2 divided by negative 2 is 1, so I'm keeping x, I'm keeping greater than, 10 divided by negative 2 is negative 5. But keep in mind that because we divided by this negative number, because we're dividing by negative 2 here, it's going to take that inequality symbol and it's going to reverse it. So the greater than symbol actually becomes less than, and my answer to this inequality is x is less than negative 5. So remember that because we divided by a negative number, that inequality sign gets reversed, and we're going to be we're going to have less than as our answer here. So what does that answer mean? Yeah, it means that any number that's less than negative 5 is going to solve this inequality. So what numbers would that be? What numbers are less than negative 5? Right, negative 6, negative 7, negative 8, so on and so forth. Well, let's pick one of those and let's make sure that we actually did this correct and that we reversed the inequality symbol correctly. So we said that we could use any number that was less than negative 5, such as negative 6, negative 7, negative 8. Well, let's just use negative 6 here. So if I go back to my original inequality of negative 2x is greater than 10, and I choose a number that's less than negative 5, such as negative 6, negative 2 times negative 6 is 12. Is 12 greater than 10? It is. So that means that this answer of x is less than negative 5 is correct. It means that we reverse that inequality symbol correctly. Because remember that when you multiply or divide by a negative number, that's when that inequality symbol gets reversed. Great work, guys. Today we reviewed how to solve inequalities. We talked about these three main things here. We found them out by doing some numerical examples, that when you add or subtract, the inequality sign doesn't change. That when you multiply or divide by a positive number, the inequality sign doesn't change. but that when you multiply or divide by a negative number, that's when that inequality sign gets reversed. I hope you're seeing some connections to regular solving, but also remember those special cases about multiplying or dividing by a negative number. You really did a great job today. After this video is over, you're going to have some problems to practice on your own. Good luck, do your best, and keep these things in mind as you work through. So, for the individual practice, so we can go ahead and look at it and think about what your independent practice is going to look like, you can access that online, and it's going to ask you to solve each inequality and then justify your answers. So the first example that we can look at together, just so that you have an idea of what you're going to be doing on your own, says x minus 7 is less than or equal to 9. So just like we did together a second ago, you're going to be thinking through how to solve this inequality. So the inverse operation of subtracting 7, the inverse of that is adding 7. So I'm going to add 7 to both sides. So x is less than or equal to 16. Now, what we have to think about is, does that inequality symbol need to be reversed? Because we just added or subtracted, that inequality symbol does not change, and x is less than or equal to 16 should be our answer. Now, the instructions tell you to justify your answer. That's what we were doing together when we picked one of those numbers to see if it actually worked. So you need to pick a number that's greater than or equal to x needs to be less than or equal to 16. So you need to pick a number that's less than or equal to 16, like 15, and take that number and substitute it into that inequality and see if it works out. And if it does, we know we did this correctly. And if it doesn't, you may need to go back and think about what we talked about today during the lesson. Okay? So, guys, I've really enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning series. Bye!